Hi everybody, hi. Welcome to our new normal. So this is for my calculus classes, both scientific and business. We're going to try and pick up where we finished. Remember, just like before, I'm going to write down the title so that if you want to go online, and I will put some links to Khan Academy to save you some searching if you want to do other practice problems. On CourseWeb, I put some problems for what we're going to do with using integration to find an original function. Because, remember, when you're doing f prime, you're finding the change. So you can look and say, okay, this is the change in what's happening over time, and then you can back into the original function, use that to project out into the future, which right now with COVID-19 is being done in spades. So I hope everybody's well. We're all going a little bit nuts, and I miss you all so much. Anyway, so let's do this math stuff. Get your math brain warm. Okay, don't forget y equals f of x. Okay, we're in my bedroom, by the way. Okay, so f of x is our position function because it gives us the value of the function for any given value of x. So if this is our x-axis and our y is f of x, and let's just say I have f of x equals x squared. Okay, my function would be going like this. So for any given value of x, I can find out what's going on with y, hence the word position. Now, if we know the rate of change of something, f prime, that's our velocity function. Because remember, that's going to give me my instantaneous rate of change, okay, which is speed with direction. Okay, now, if I know how fast something is changing, if I take the integral of it, that takes me back to the original function. Like that. Okay, so it's like a step-down thing. These are actually really, really simple. I opted to do this with both my calculus classes rather than to dig into some of the more difficult trig stuff for the first lecture. So, just bear with me. Okay, f double prime. That's our acceleration function. So, the rate of change of the rate of change. If I want to find f prime of x, I just integrate f double prime of x. Okay, so the integral of acceleration gives me velocity, and then the integration, like I've written before, of my velocity function gives me my position function. Okay. Okay, so suppose that we are given that f double prime of x is equal to, say, x cubed. Okay, and I know that f prime of 0 is equal to 2, and say I know that f of x, say f of 1 is equal to 5. That's a 1. Okay. So if I have this information given to me, I want to find f of x. So I'm going to try and find the position function based on this information. Well, I'm going to use this, I'm going to integrate this, and that'll give me f prime. But remember, these are indefinite integrals, so I'm going to have that arbitrary plus c, remember, for the constant. So that's where this information is going to come into play. So f prime of x is equal to the integral of f double prime dx. Remember how to integrate? Wonder if I do. Okay. So we're going to have x to the fourth power over 4 plus c. Then we use this information that I gave to you. Okay, so this is telling me that for f prime, for my velocity function, when x is 0, the velocity is 2. So if I put a 0 in here, 0 to the fourth is 0, or 4 is just 0, equals c. So I have 2 equals 0 to the fourth over 4 plus c. Therefore, c is equal to 2. So that tells me that f prime of x is x to the fourth over 4 plus 2. Okay, so we're halfway there. This is what I'm trying to find. So now that I have an exact amount for f prime, I'm going to integrate this, and then I'm going to have a plus c, so I'll use this information to find out what that c is, and that'll give me my position function. I'm just going to write this stuff up here. Okay, so f of x is going to be x to the fifth over 4. Well, you know what, just to make this a little easier for you to understand, I'm going to write this as 1/4 x to the 4. Okay, it's just a little bit easier to integrate written like that. Certainly isn't wrong if you do it the other way. Okay, so I'm going to have my 1/4 x to the fifth over 5 plus 2x plus c. So that gives me f of x is equal to x to the fifth over 20 plus 2x plus c. This is where this comes into play in order to find c. So we'll use, and this is given in the problem, f of 1 is equal to 5 to get this c. Okay, so f of x is going to be, the whole thing's equal to 5, and then replace both of those x's with a 1. You can use your calculator if you want. Okay, so 2 plus 1 divided by 20 okay. So here's going to be, how's this going to work? Okay. Okay, so then replace the c with 2.95. This is a 1 to the fifth, not a 15. Okay, so that gives us the answer to our question. Okay. All right. Let's try this one. This will be example number 2. I'm going to use zeros because that's easy. And I'm going to erase this because no, I'm not going to use 0. I changed my mind. Makes it too easy for you. There. Okay, so these, like anything with math, once you do a couple of them, they're really easy. The only difference between this problem and a more complicated one is there's more fractions. You have a calculator. So, okay, so our first thing is to find f prime of x by integrating f double prime. So the integral of x squared, that gives us x to the third over 3. And the integral of negative 3x is negative 3x squared over 2 plus c.